This question was one of the tougher ones in 2010 and the tougher ones forever, because the national average on this question was 1.75 out of 9. Let's try to figure out what makes it so hard. We're given a graph of G prime. That's probably going to be important that it's G prime, not G. It tells us G is defined and differentiable on the closed interval -7 to 5. We see -7 to 5 is represented on this grid. And we know G of 0 equals 5. That G of 0 equals 5 is one of our initial conditions, maybe our only initial condition. It tells us y equals G prime of x is the derivative of G, has a semicircle, which we can see in the picture, and 3 line segments that we also see in the picture. So a semicircle and 3 line segments. Part A tells us to find G of 3. That'd be real easy looking at the graph if we had the graph of G, which we don't. We have the graph of G prime, which is how much G is changing. So if we want to explore that idea, we're going to have to say we know what's going on at 0, and let's find out how much G has changed from 0 until 3, and then we're also going to find out how much G changed from 0 to -2. So let's explore those two ideas. So for G of 3, we know what's going on at G of 0, and we're going to add to that what's going on from 0 to 3. We're going to find out how much G is changing from 0 to 3. And to figure that out, we just need to find the area under the curve of G prime x from 0 to 3. That requires a little bit of geometry. I'm looking at this graph of G from 0 to 3, and I notice I have a semicircle, but it's really a quarter of a circle if I'm just looking at 0 to 3. 0 to 2 gives me a quarter of a circle. I know the radius of that circle is 2 by looking at the graph. So the area of that quarter of a circle would be a quarter of pi r squared. In this case, r is 2, so that area of my little red quarter circle is pi. I also need to figure out my area from 2 to 3. We've got a little triangle here. The base is 1. The height is 3. So 3/2. So if I want that total net change from 0 to 3, I'm going to have pi plus 3/2. So we go back and apply that in part A. I know my G of 0 is 5. It was an initial condition. Plus my net change from 0 to 3, we just noticed was pi plus 3/2. And that's perfect. That gives you full credit for G of 3. G of -2 is a little bit trickier. I'm guessing this is probably where some points were definitely lost. We have to go back and find what's happening for G of -2 by saying what happened at 0, and then look at the net change from 0 to -2 of G prime of x. The place I expect to see people make a mistake is not realizing that those limits are kind of backwards from what we normally see and expect. We'd rather see something like -2 to 0 with the smaller limit on the bottom. But if we're going to do that, we have to change the sign from positive to negative. At this point, we just need to figure out that net change from -2 to 0 and apply it. So we'll go back up to that graph and see what's going on with G prime of x from -2 to 0. I'm going to switch colors here. My -2 to 0 looks like another quarter of a circle. And it looks like my net change from -2 to 0 is pi. I don't need any triangles or anything like that this time. It's just pi. Using that information, I can go back down and apply it. Just like in the previous problem, g of 0 we know is 5. It was our initial condition. Minus the net change from -2 to 0. G prime x is pi. You're done. 5 minus pi. That's it for part A. The way the scoring guideline worked on this, you got 1 point for somehow using the fact that g of 0 equals 5. You got 1 point for the correct answer for g of 3. 1 point for the correct answer on g of -2. Part B is worth 2 points. It's asking us to find the x-coordinate of the point of inflection of g, not g prime, g. If we want a point of inflection for g, we want to look for places where g prime of x is equal to 0 or undefined. Does not exist. So we have to look and analyze how that's going to play with the graph of g prime. As you hopefully remember, g prime double x equals 0 is the same thing as asking when the slope of the slope, or the slope of g prime, is 0 or undefined. And that happens in a few places. We have an undefined slope of g prime here. We have a 0 slope on g prime here. Undefined, undefined. So it looks like we have 4 candidates, points of inflection of g. And we're going to have to explore all 4 of those separately. We're going to look at x equals -2, x equals 0, x equals 2, and x equals 3. Continuing with that idea that the second derivative is looking at the slope of the slope, or the rate of change of the slope, looking at -2, the slope of the slope goes from positive to positive. That's not an inflection point, so that one's gone. At x equals 0, the slope of the slope goes from positive to negative. That's a winner. At x equals 2, the slope of the slope goes from negative to positive. Since the slope of the slope changed, we have an inflection point. And at 3, well, x equals 2 is a winner. At x equals 3, we go from a positive slope to a negative slope on the slope of the slope. So once again, point of inflection. Going for the full points there, you need to identify the points of inflection. That would be x equals 0, x equals 2, and x equals 3. And it also asks you to explain your reasoning. And one way you might explain that is you might say, at x equals 0, the slope of g prime changes from positive to negative. You could also say g prime goes from increasing to decreasing at that point. As long as you say things and use the right words with the right function, g, g prime, g double prime, you're going to be okay. You should say something like that for each of those 3 points. To get the full credit, the first point was identifying 0, 2, and 3. If you would have included -2 in there, you would have lost that point. And you get a point for your full explanation. Any mistakes in that explanation, and you would lose that point. Part C. In my professional opinion, these 4 points have 3 points that were very hard to get for a lot of people. I'm guessing that's where a lot of the issues came from for this low average nationwide. It says we've got this function h of x equals g of x minus 1/2 x squared. It says find the x-coordinate of each critical point of h. Right then, you should stop and think, where do critical points happen? They happen when a function's derivative is 0 or undefined. Which means we should probably start by looking for the derivative of h, which isn't too bad. This is the one of the 4 points I think most people would get. You get your h prime x equals g prime x minus the derivative of 1/2 x squared, so minus x. Drop the 2, cancel the 2's, lower the exponent by 1, using the power rule there. So we want to know when this equation is undefined or 0. So let's look at 0, which is really saying we want g prime of x to equal x. Looking at the g prime graph, I think a lot of people are going to notice that g prime of x equals x at this point, and they're going to examine x equals 3. What they're not going to notice maybe is the tricky point. If we look at the line y equals x, that line intersects this graph not one time at 3, 3, but also right here. And I bet that's a hard point for people to find. One way we could find it, we know that's a circle with a radius 2. So this little red piece right here is defined x squared plus y squared equals 4. It's a circle with center 0, 0, radius 2. Because we want g prime x, which is this equation, to equal x, we know x and y have to be the same. Similar to what we see here. 3, 3 are the same. We need x and y to be the same at this guy too. So we could say something like x squared plus x squared equals 4, because we need x and y to be the same. 2x squared equals 4, x squared equals 2, x equals plus or minus square root of 2. One of these two x's can be thrown out. Just looking at the graph, if we had to decide if that was x equals square root of 2 or negative square root of 2, it should be pretty clear why that would be square root of 2 comma square root of 2 instead of negative, because we're in quadrant 1. So what we just did was we found two places where the derivative of g was equal to x, or in other words, the x and y coordinates were the same on g prime of x. To deal with the other piece, h prime of x undefined, that's not going to happen anywhere on this interval, because g prime of x is defined everywhere on this interval, and x is defined everywhere on this interval. So their difference must also be defined. We would just subtract y values. So we don't have to worry about the undefined piece. We now have two critical numbers. X equals square root of 2, x equals 3. And we'll explore both separately, starting with x equals square root of 2. If we look at some intervals surrounding square root of 2, like -7 to square root of 2, comma, square root of 2 all the way up to 3, and then 3, 2, where do we stop? 5. Looking at the square root of 2, choose numbers smaller than square root of 2. I'll just go circle one. Our g of x, g prime of x, is going to be bigger than square root of 2, minus square root of 2, using my h prime x formula. That's going to give me a tiny positive number right there. If I go a little bit to the right of square root of 2, and I try to figure out g prime x minus x, I get a number close to square root of 2, but a little smaller, minus square root of 2, which is a negative. What that's going to tell us is we had a local maximum at square root of 2. Let's continue on and look at what's going on at x equals 3 also. If I choose a number a little bit bigger than 3, so I'll circle a point like that on the graph, that's going to give me a number smaller than 3 for my g prime of x, minus 3, which is a negative number. So we went from decreasing to decreasing, which means nothing happened. So you really have only one local extreme. That's going to be at x equals square root of 2. And you'd explain why, saying that h prime of x goes from increasing to decreasing at that point. Or you could say that the slope goes from positive to negative at that point. For 3, you'd give a similar analysis, except you'd say that the slope went from negative to negative, so there was no change. Or you could say it was just decreasing the entire time. Don't say it is a bad word. You could say h is decreasing the entire time, or it's h prime stayed negative. And there were 4 points here. One for the correct identification of h prime of x. One for identifying square root of 2 and 3. If you only identified 3, you lost that point. 1 point for your square root of 2 analysis, coming up with the fact that it was a local maximum. And 1 point for your analysis of 3, coming up with the fact that there was no max or min there. That's it. That's your full 9 points on 2010 AB number 5.